Goal, BritishTOmetric conversions, and vice versa. Here we cannot simply move the decimal to perform unit conversions. Unlike the metric system, British units do not involve powers of 10. For example, 1 foot is 12 inches, not a power of 10. 1 yard is 3 feet, and 1 statute mile is 5,280 feet. So what we have to do is to multiply by a 1, since anything times 1 is itself. For example, 17 times 1 is 17. Pi times 1 is pi, and so forth. How do we use this fact to change units? We pick an appropriate conversion equation that has a unit that we want to replace and the unit that we want to obtain. For example, suppose we want to know how many yards 19.3 feet are. So we need to go from feet to yards. So what is the appropriate conversion equation? That would be 3 feet is 1 yard. But there are two possible unity fractions, or ones, that could be made with this. Since 1 yard is 3 feet and anything over itself is a 1, then 1 yard over 3 feet is a 1. But the reciprocal would also work, since 3 feet over 1 yard is a 1. So which one do we want? We notice that the 19.3 feet is really in the numerator, because there's an implicit 1 for the denominator and we don't have to write 1. So we say we have feet, we want to replace the feet with yards. So we form a unity fraction using the fact that the feet are in the numerator, and so to cancel the feet we need this one since the feet are in the denominator. So we write the unity fraction 1 yard over 3 feet. Now that is a 1, the reasons discussed. Okay, so we're multiplying by 1. We're not changing the quantity, we're only changing the unit. Then we see that we have a foot in the denominator, which cancels the foot in the numerator. We use the terminology canceling, but it's really erroneous, because what we're really doing is removing a 1, and so since a foot is a foot, then that means that a foot over a foot is a 1. And so we're removing the 1, we don't have to write the 1. So whatever, 19.3 divided by 3 is how many yards we have left. We do the calculation and what we get is 6.433, repeating on and on. We have to understand 19.3 is 3 significant figures, 4 significant digits. Any digit that's not a 0 is significant. We cannot have an answer that's any more accurate than the least accurate number that's used. And accuracy is defined to be the number of significant figures. We have more than 3 significant figures here. To comport with rounding conventions, we report this to 3 significant figures. The decision point is right here. So if this were a 5 or greater, this would be 6.44 yards, but it's not, so we truncate, and what we report is 6.43 yards. Keep in mind that if we were using this result for further calculations, we would carry the extra significant figures so as to not propagate round-off error. Demonstration problem 1, 7.25 yards is how many meters? First thing we have to do is to come up with conversion equations that take us from yards to meters. There are many possibilities, but what comes to mind is 1 yard is 3 feet. That's exact. That will not limit the accuracy of our result. Also, 1 meter is 3.28 feet. That's rounded to 3 significant figures. 7.25 yards is also 3 significant figures accuracy. This means that our answer can have no more than 3 significant figures of accuracy. The first thing we do is to multiply by a unity fraction. We take the 1 yard is 3 feet. We see that the yards are in the numerator, and therefore the unity fraction needs to have the 1 yard in the denominator. This is so that we can cancel or remove a yard over a yard, which is a 1. This means that 3 feet goes in the numerator. 7.25 times 3, that's how many feet we have. So now we need to multiply by another 1 to disappear the feet and to get meters. We create another unity fraction. We need to get rid of the feet, put the 3.28 feet in the denominator, and we put the 1 meter in the numerator. The feet are gone, and we have meters. Whatever 7.25 times 3 divided by 7.28 is, That's how many meters we have. That number comes out to be 6.63109. There are more digits, but since we know that we must round our answer to 3 significant figures, we lose interest after we write the 4th significant digit. Our decision point is right here. We see that 1 is not at least 5. Say equals to 6.63 meters. Demonstration problem 2. 700 gallons per minute is how many liters per second? Our conversion equations, 1 gallon is 3.785 liters. That's 4 significant figures accuracy. 1 liter is a big quart. A liter is 1.06 quarts. 1 gallon has 4 quarts. Since a liter is bigger than a quart, it makes sense that a gallon has fewer than 4 liters. In fact, a gallon has 3.785 liters. The other conversion equation we need is 1 minute is 60 seconds. To convert, we want to get rid of the gallons and replace them with a liter. We put the 1 gallon in the denominator. The numerator is 3.785 liters. Gallons are gone. We now have liters. To eliminate the minutes and change them to seconds, we see that the minutes are in the denominator. So in this conversion equation, we put the 1 minute in the numerator. That takes out the minutes in the denominator. Put 60 seconds in the denominator. We then perform the calculation. We need to know what 700 times 3.785 divided by 60 is. Our result is 44.583. Repeating, we know that if we consider 700 to be exact, that we've used a 4 significant figure accuracy number. We have to round 4 significant figures. We make our decision point right here. What we get is that 700 gallons per minute is 44.58 liters per second. Demonstration problem 3. 60 miles per hour is how many feet per second? Conversion equation. 1 statute mile is exactly 5,280 feet. 1 hour is exactly 3,600 seconds. Unity fraction is 1 mile in the denominator. Cancel the mile. 5,280 feet in the numerator. 1 hour is in the denominator. Put 1 hour in the numerator. Cancel the hour. 3,600 seconds in the denominator. We're left with feet per second. This answer comes out to be exactly 88 feet per second. Now that you have seen some examples, it is your turn to try some problems.